In this video, you will learn about the crucial role of data in machine learning pipelines. We'll explore the distinctions between tabular and unstructured data and how they are used in both classic and deep learning models. Classic learning has limitations in the types of data it can use, while deep learning has no such limitations. As shown in the pipeline diagram, data is the backbone of any machine learning model, and it's present in two ways. First, we need data to train a model, and second, we also generate data when we use the model and predict with it. Both input and output data are essential. Input data because it's the examples used to train the model, and the output data because these are the predictions. Both input and output data always fall into one of two possible categories: tabular or non-tabular. This classification determines which type of learning or algorithms we can use. Because classic learning, which is simpler but still efficient, can only handle tabular data, while deep learning, which is more complex and versatile, can handle all types of data. Tabular data, as shown in this example, consists of rows and columns. Each row represents a record, and each column represents a variable or feature. For example, a column can be the opening price, or the volume or the 7-period moving average, while the rows may be those data for each date. This structured format is typical in databases, spreadsheets like Excel and common CSV files. On the other hand, take a look at the right side images. Non-tabular is simply data that we cannot place in a table, and this is the reason why we call it unstructured data. This data includes images, sounds, and also text. These types of data do not fit into rows and columns. For instance, images can contain a vast array of pixels. Sounds consist of varying frequencies and amplitudes, and text is composed of sentences and paragraphs. Deep learning algorithms can handle these types of data, and this ability is a major reason for the hype surrounding artificial intelligence since 2014. Deep learning can manage these data types both as input and output, generating text, images, and more. Although deep learning attracts more interest, it's important to first master classic learning to avoid novice mistakes in deep learning. In classic machine learning, we typically use both input and output data in a tabular format. In technical analysis, we employ images that requires deep learning but also a multitude of tabular data, such as technical indicators. Data in a tabular format means that the features, the predictive data, used to train the model and the predictions made by the model are organized in a structured manner. Deep learning models, however, can handle both tabular and non-tabular data. For instance, a deep learning model might take an image as input and produce outputs in various formats, such as tables, text, sounds, or even another image. Here, we see an example where the input to the deep learning model is images. Since we are using non-tabular nor non-structured data, we need deep learning algorithms. These images shows the evolution of the price of several equities like Boeing, Chevron, and Coca-Cola. The model is designed to calculate the most relevant support levels for prices. Even though the input consists of images, the output can be presented in a tabular format, as we see with support levels for Boeing, Chevron, and Coca-Cola. But we can also get the output as text, annotations, or even rich text. We can get it as sounds or directly plotted in the chart. In conclusion, understanding the types of data and their roles in machine learning pipelines is essential for leveraging the full potential of both classic and deep learning models. By mastering these concepts, you can enhance your ability to build and deploy effective predictive models.